All right, so I'm going to highly encourage that you try this problem on your own. It's very similar to the problems that we were doing just before. If you want to do that, feel free to hit the pause button right now. Try it, unpause it, and let's get on with it. All right, so hopefully you did that. You paused the video, tried it on your own, and if not, that's okay. We could just run through it right now. So the first thing I'm going to do is write out our quantities. All right, so it says a car moving too fast on a horizontal stretch of a mountain road slides off the road, falling into deep snow this many meters below the road. Okay, so it's falling that many meters below the road. Okay, so we have this over here. So what is it telling us? Well, it's telling us the initial height, right? The assumption here is that it will be striking the ground, but we'll read on and make sure that that's true. And 87.7 meters beyond the edge of the road. All right, so what is that telling us? Well, this is going to equal to 0, and this will be our 87.7 meters. I'll pull this aside. Okay. How long did it take the car to fall? All right, so what is that asking us? Well, if you're saying to yourself delta t, and how fast was it going when it left the road? What was the acceleration 10 meters below the edge of the road? All right, so this is going to be something here that we'll discuss at the end of the problem. That's the reason why I didn't include that answer over here. All right, well, what's the rest of the information that we could be filling in here? Well, do we know what the final height is? It's going to be hitting the road. So, it's going to be hitting the ground. So we're going to say that that's equal to 0 meters. What about the initial velocity in the y direction? Well, once again, it's the object is being launched out to the right. It's not going to be launched on an angle at all, either upwards or downwards. So there's not going to be a y component as far as the velocity goes for this problem. So we're going to say that that's going to be equal to 0. And what about this over here? Do we know the velocity, the downwards velocity at which it'll hit the ground? No. Okay. And it doesn't really seem like that we care about that piece of information either. What about the acceleration due to gravity? And being that I didn't really give myself too much room over here, I'm just going to take this and shrink it down a little bit. Just like so. And I'll get rid of this. Put that back in there. All right, so let's start getting into this problem now. What do we want to try to find first? Well, we have this Vx over here, the delta t. We know that Vx, the only place that it's actually being found in our formulas is right there, but we also have our delta t. So we do know that we'll be using this formula over here, but the very first thing that we'll need to find will be our delta t. And then we could find our Vx from there. So being that this is a piece of information that we don't care about whatsoever, we're going to come through our formulas and cross out wherever we see the VFY. Just like before, we're going to be using this formula, that being the case. And let's just write this out. Once again, don't forget that squared right there. That's very important. And let's plug in our given information. Make sure you're plugging in the correct Y information. Don't plug in your X information. I did this once before in the past while I was practicing out these problems before displaying them. And yeah, don't make that mistake. And we know this middle term over here, anything that gets multiplied by 0 is equal to 0, so that cancels out. I'm not really going through the explanation of the algebra over here. I feel like by now you should have a good grasp of that. Okay, we don't care what delta t squared is equal to, so we're just going to take the square root of both sides. You know what? Instead of looking at this as 8.96, can't we just... I know that rounding is not really the best thing to be doing, but in some of these situations, we could just do a little rounding here, just saying that that's equal to 3 seconds as our delta t. For a situation like this, we could round this to 3 seconds. Maybe if we're to do some sort of scientific experiment, and this is a very, we need precision down to t. In a situation like that, maybe you don't want to round. But in this situation where we're saying, hey, you know what? It's not 10 seconds. It's not 1 second. It's 3 seconds. All right. So now that we have our delta t, we could plug it in here to find out our Vx. And we have our Vx being equal to 29.2 meters per second. All right, so we got our answer right there. We got our answer right there. Things are looking good. But the last question is, what was the acceleration 10 meters below the edge of the road? So we're looking for our acceleration at 10 meters below the edge of the road. Okay, well, don't forget about this. I know that we've been really referring to our acceleration in this term over here. We have our acceleration due to gravity. And does acceleration due to gravity ever change? No, throughout this entire object's trajectory going through here, what is the acceleration in the y direction? The acceleration in the y direction, which is acceleration due to gravity, is going to be always negative 9.8 meters per second squared. That's going to be the acceleration in the y direction. So in the y direction, it's going to be equal to this. What about the acceleration in the x direction? Think about this. What is acceleration in the x direction? Well, we know that the velocity is going to be the same in the x direction all the way throughout. If it's the same, is there acceleration? If the velocity is not changing, is there acceleration? Hopefully you're saying to yourself, no. So in the x direction, the acceleration is equal to 0. And that's it for this problem.